Good morning. Wow.
There are a few people awake.
Responsive audience. This is great. So welcome to Continuous Availability with Windows Server 2012. We are here to give you an overview. This session is pretty much an overview of a variety of different features and functionality that we've put into the server. Because it's got so many different things in it, we're not going to have the deepest dive in any of them, so there'll be several places where there are pointers to other sessions that are deep dives in particular topics, and a few pointers at the very end to sessions that we did in TechEd North America in Orlando that didn't make it onto the agenda here because the agendas are a little bit different. But I'm Gene Chellis. I'm Director of Program Management for the Windows Server Storage and Availability Group. And program management just talks and writes specs and things, but we're lucky to have Jim Pinkerton, who's the architect for the group, who's going to be able to tell you, answer all your deep technical questions. So speaking of questions, I'd like to ask that you hold the questions to the end. We're going to try to zoom through the material and leave time for some interactive questions. But I'd like to make sure that we do get through the material and then focus on the things that you'd like to talk about in particular. So let's get started. Why availability? Availability has always been something that was an issue. But it wasn't always quite as important as it is today. Why is it particularly important now? Well, it's due to some changes in trends in technology where servers have gotten bigger, gotten better, and we have virtualization. So the result is that you end up with a lot of servers, a lot of services being put onto bigger machines, more consolidation. So with all those eggs in one basket, as we say in English, the risk goes up. So availability becomes something that's more important if you've got 1,000 servers or 1,000 services running on a machine. You've got to make sure that that stays up, otherwise lots of things go down. Beyond that, customers or users have just come to expect that IT just works. So if it's going to just work, it has to stay up. We talked to a lot of customers in putting together the planning for Windows Server, thousands of customers. And there were some consistent themes, not just in the server storage and availability portion of it, but across all of the planning for server. Customers told us the same thing. It's really important. Don't lose my data. That came through everywhere as one of the top 3 things in just about every session that we did. Don't lose my data, keep my services running, and oh, by the way, help me keep my business running. So we're going to talk about that range of different kinds of availability. We're going to talk about the range for all the way from the single server and data on disk up through clustered servers, multiple servers put together, and then how do we think about or help you with availability in the sense of simple disaster recovery of multi-site availability.
That's the polite version of what our customers gave us for feedback. The more slightly impolite was, my service is down, and it's down for 10 minutes. That's absolutely unacceptable. How do I get it so that I can be continuously available? It's around moving that bar so that the service is always up, and the system administrator and the IT administrator and the storage administrator just work. They don't have to worry about these crises.
So a little bit about how we think about it. So availability matters both for planned and unplanned events. If the server's down because it went down and you have to get it back up, or the server's down because you had to take it down in order to patch it or fix something, it doesn't matter from the user's perspective. The service is down, it's unavailable, it's not part of your uptime. So availability was about reducing the frequency of events that would cause failures or downtime, and then being able to manage the consequences of failures or required downtime when it occurred. So we focused on the service itself, make the service available, even though you know that something will happen and something in IT always breaks eventually or has to be repaired or replaced or updated. So there will be events. We're not going to be able to get away from that, but you manage the service to make it more available. So we've had availability around in the IT industry for a long time, and Windows has talked about availability with Windows failover clustering. So we've had the ability to automate the process of restarting a service. When we went to building the plan for Windows Server 2012, we decided to take another definition of what we meant by the availability that we wanted to be able to deliver to customers. So we came up with this term that we called continuous availability. Continuous availability, or sometimes you'll hear us refer to it as CA. Continuous availability is software and hardware that can support transparent failover without data loss. Well, what does transparent failover mean? Transparent failover means the user or the consumer of that service, whether it's software or human, shouldn't have to worry about it. So failover, if a component fails over, the system should take care of that, should be able to survive planned or unplanned events without data loss and without the consumer of the service being interrupted. So with that goal, let's go talk about some of the things that we did in Windows Server 2012.
To me, at a high level, when you look at the goals that Gene just outlined, it means we have to make a couple of really big bets that you'll see the theme across our talk. One big bet is that it needs to be easy to deploy multi-node systems that can be continuously available. It's a huge bet for us that clustering that allows you to be able to deal with these systems as a single system rather than having to manage individual nodes has to be easy and pervasive. Another big bet for us is storage. We need to be able to get to the point where storage on Windows natively can be reliable and available.
So what we hope to do today is to show you how you can increase the availability of your systems and services with Windows Server 2012, show you a little bit of how to do it, and to have you be able to walk away from this saying, that's easy. So we have this term called active on that ties back to the definition of continuous availability. And you'll see this in some tags through the deck. Active on is a term that we're going to be using to indicate technologies that meet that kind of criteria of being able to survive loss or failover without losing data and without interruption in the service. So let's start at the single node. At the single node, you don't have a cluster, but you still want that service to be as available as possible, and you still have that thing that customers want, which is don't lose my data. So with that, we looked at how we deal with disk error protection. We're going to talk about a couple of the technologies that we introduced or improved to be able to deal with that. So first, if I can make this work, let's talk about the resiliency that's built into the storage system. So there's a new software storage layer in Windows 2012.
Yeah.
It's a little complicated. Some people have had some questions about it. Can you tell them what it is?
It's actually a very easy thing to deploy. In Windows Server 2012, we wanted to be able to solve this issue around downtime due to disk failures in the operating system, not requiring any external intelligent storage, but actually be able to take JBODs and make those JBODs reliable and available. So we created a new feature we call storage spaces that allows you to virtualize those disks, those physical disks, into a pool, and then out of that pool create what we call a space. That space can then be provisioned as a simple space, a mirrored space, or a parity space. A simple space is unreliable. It's simple. A mirrored space basically will take your data and mirror it across multiple disks, say two-way or three-way mirroring. And then parity spaces allow you to have a parity disk, which would give you the lowest cost per gigabyte. So that core capability then allows us to be able to create fault-tolerant storage. And then we also support it in a clustered environment. So you can have that continuous availability. Even if a node goes down, you still have access to that data by what we call shared JBOD. So we take that JBOD, that external tray of disks, say 10, 20, or 100 disks that have been pooled together, and through using a shared SAS interconnect, can then connect multiple systems to that shared JBOD, and then with the clustering technology that we're about to talk about, be able to make that continuously available. So in the unclustered situation, where you've got a single node, we support simple parity spaces and mirrored spaces, so you have that fault tolerance built in. And then if you want continuous availability, we also support it in a clustered environment with mirrored spaces. So that gives you a little bit of an overview.
So clustering without necessarily investing in an external storage array.
Correct.
All right, so how hard is this to do? Let's take a look. So in Server Manager, as Jim said, you can create pools of disks, throw in a bunch of disks, create a pool, and then to create a virtual disk, there's a wizard for it. This is all you have to do to make that virtual disk resilient. Select the storage layout, choose mirrored, choose parity. That's it.
Now, what's underneath the covers is a little more complex than that. Because what we actually do is we take, say, 100 disks, each of, say, a terabyte apiece, pool them, so you end up with a 100 terabyte pool. And then out of that 100 terabyte pool, you can then provision, say, with PowerShell, to come in and then create a space out of that. And then on a per space basis, you can say, do I want parity spaces, mirrored space, simple space? And it's as easy as typing in the PowerShell command or the GUI that we just walked you through.
Speaking of PowerShell, if any of you did not see the session that Jeffrey Snover and Aaron Chappell did, PowerShell is everywhere. We built the UI for Windows Server 2012 on PowerShell. So if you can do it in the UI, you can do it in PowerShell. And throughout this and other presentations, you'll see us show the UI, show the PowerShell. It's one-to-one or better. In fact, there are things that you can do in PowerShell that you can't do in the UI because we put all the ability to do more complex configurations into the PowerShell interface.
This technology, by the way, in many ways is easier to deploy than RAID. Traditional RAID, you have to deal with RAID sets, and you have to deal with matched disks. Whereas with spaces, you can actually have an odd number of disks. My mic dead? You can have an odd number of disks.
While he's getting that fixed, it is not just about the number, or whether it's even or odd, but the disks don't have to be exactly the same size. They don't have to be from the same manufacturer. They don't have to have the exact same geometry. Put them in a pool, and then we'll carve out these virtual disks out of the pool.
Don't you wish the wireless LAN was that easy to fix? Just put new batteries in. Yeah.
Okay, so anybody here ever had a server that you had to run check disk on? Raise your hand. Anybody ever had check disk that ran for more than an hour? More than 4 hours? More than a day? Okay, I'm going to stop there.
Please.
One of the things our customers told us that they didn't like was running check disk. So we address that problem. You'll be happy to know that the days of running check disk for an hour, 4 hours, or a day are gone. With Windows Server 2012, that will not happen. We separated the scanning and in fact, Jim, tell us about how this works. And
it's actually,
we'll come back to the numbers.
To me, people haven't honestly been keeping up with the innovations we've done in check disk, the chart that we've got up here is how fast we do check disk in Windows Server 2008 R2. Some of you probably have seen longer times than this. Check disk back in Windows Server 2000 or 2003, for example, could run radically longer than these times. The blue chart is Windows Server 2008 R2. So just to acknowledge your pain, we've had a lot of feedback over the years on how tough check disk is on our customers and have tried to improve it. But really, with Windows Server 2012, we took a radically different approach. We weren't just doing incremental improvements. We were completely changing the approach. Now what we do is we actually do the volume scan on a snapshot. So the volume itself is never taken offline during the scan to understand if there's any issues with the disk. It's only after it finishes the scan that it creates a list of potential corruptions in the file system, and then you can then take the file system offline just long enough to fix those. And so therefore, you see in orange, which has been grown substantially just so it shows up on the chart, the actual amount of time goes down into the order of seconds. And in fact, if you're in a clustered environment with clustered shared volumes will even keep the handle valid the entire time you bring the disk offline to do the check disk. So from an applications perspective, all you have is the IOs stall for a very short period of time while you run the check disk. While underneath the covers, the volume is actually unmounted. You fix, say, the 2 or 3 or 4 corruptions that are on the file system instead of trying to do an entire scan of the file system, and then bring it quickly back online and rehook up all the handles, and so the application itself never sees any errors. So it's a radically different approach than what we've taken in the past, and hopefully make a huge difference for you guys in terms of how easy it is to have a continuously available server.
So how cool is that? We've gone beyond check disk, though. In Windows Server 2012, there's an entirely new file system.
Yeah. That we got feedback from customers that what was happening on top of NTFS, even if they're on the highest end, most reliable storage in the market, they were still seeing file system corruptions. And when we went into root cause analysis of it, what it really comes down to is disks are getting so big that the probability of a single sector silently going bad is getting pretty high, particularly as we go into the 3 terabyte or 6 terabyte size disks. And then you try to aggregate that across, say, 50 disks or some reasonable number to make it so your pooling works. The probability of seeing corruption is only going up. And so we recognized that actually several years ago and invested in a new file system that's intended to work well on storage that actually goes bad on you. Previously, with NTFS, we've always made the assumption that we sit on top of reliable storage. And honestly, we've been fixing some of those assumptions in terms of check disk. Clearly, at times you do get corruptions. And so being able to recover from that radically quicker than we have in the past. And then also with NTFS, we've done a lot of analysis in terms of metadata corruptions and being more tolerant of those corruptions. And so, in fact, a lot of the check disk reasons in the past were actually false reasons. And so we tracked down a lot of those issues in Server 2012 and made it so that we actually will online figure that out and not ever have to do check disk to begin with. But even with all those innovations to be able to improve our resilience, the bottom line is the file system itself cannot check data integrity with NTFS. With ReFS, what we did was we said, let's take a completely different approach. Let's take an allocate on write approach so that we never overwrite data structures. We just simply write them to a new location and then change a pointer to that new location in an atomic way. And so you either have all your data before or all your data after. There's never an override in place, so you've got some of your old data, some of your new data. And so in terms of metadata for the file system, it makes a huge difference. Now we can always say, since we have checksums on all of the metadata at all times, we can pretty much always detect if there is a corruption, and then hopefully have that second copy sitting there so we can dynamically fix it on the fly. And then if that second copy is also corrupt, we can at least just prune that portion of the namespace so the rest of the file system stays online. That's for metadata. And then for data, We have what we call integrity streams, which are optional. You don't have to turn them on. We certainly suggest it, particularly for large data stores. For databases, on the other hand, you may not want to, because there's a performance hit, because we're always doing what's called allocate on write. But the bottom line is, if you enable an integrity data stream, which you can enable on a per volume, a per directory, or per file basis, that allows you to have checksums on all of your writes. And so any read that comes back, we will do the data integrity check, and if you've got redundant storage underneath the covers, ReFS will automatically detect that corruption and then query the underlying storage infrastructure to ask for a second copy if one is available. If one is, it'll then check that. If that check's okay, then it'll fix the original copy and then keep right on going. This is all done transparently, fully on the fly. So the old days of silent bit rot are gone. We also have a groveler that goes through periodically at the administrator's choice to then grovel in the background to make sure the silent bit rot that can happen in these very large disk subsystems are now also protected. So with ReFS, we now have the ability to be able to sit on top of mostly reliable storage, just not always reliable, and still be able to work continuously in that environment.
So check it out. There are some places where ReFS and some of the capabilities that we will be talking about here and other places in the conference are not fully integrated. ReFS is a long-term project, but expect to see there's great things that you can get from it now, and expect to see ReFS as the file system for Windows in the future as we go forward.
That is a really good point. So this is version 1 of ReFS. It's solid, rock solid, and reliable, but what we haven't been able to do yet is tie every single service on top of it, or necessarily have every single attribute of the file system within it. And so, for instance, alternate data streams are not enabled on ReFS today. So there's some services, if you're looking to deploy ReFS, you want to be careful to make sure that you understand what actually works on top of ReFS. But it is rock solid. Honestly, it's targeted towards cloud properties, because that's exactly where people tend to deploy the most cost-effective, shall we say, the cheapest storage, which also has the highest probability of data corruption.
So we focused on availability, as we said, and really prioritized making sure that the scenarios that worked, and there are some that we will deliver later. All right, so let's turn from storage for a minute. I've still got a single system, don't have a cluster yet, but I've dealt with my data on the disk. Now let's talk about memory. So imagine I've got a Hyper-V server, and I've decided to put a lot of Hyper-V VMs on that. And so I need lots of CPU, I need lots of memory. I've got 1 terabyte of memory on that. How reliable is that memory? And then when it fails, what do we do?
Yeah. So previously, as I'm sure you know, with Windows Server, we require for a system to pass logo, it has to have CRC memory, CRC-enabled memory. And so we can tolerate the class of errors that CRC can recover from, and that always recovers transparently. The problem is on these massive memory subsystems that you folks are putting together, that is wholly insufficient. The thought of having 1 terabyte of RAM and counting on all terabyte of RAM working all the time with no failures can potentially cause hundreds of VMs to go down today with Win2K-R2. If you get a permanent failure in one of those DIMMs, it'll bring the entire system down. With Windows Server 2012, we now support memory fault isolation. And so now if there's an unrecoverable memory error, what will happen is, if you're running in Hyper-V, for example, Hyper-V will then get the alert of that. This is bullet 2 up here. And it will then isolate whether that memory fault was in a region of memory that was unused, a memory region that was used by a VM. If it was used by a VM, it can then query into the VM, and if that memory is unused by the VM, then it will just free it. It won't panic anything. If it is being used by that VM, then it'll just bring down that specific VM. It won't bring down the entire system. And so therefore, you can now isolate these faults and then continue on running, and that bad DIMM is then mapped out of the memory subsystem, and you're still up and running.
So even in the worst case of I have the bad memory and it affects a virtual machine, all the rest of the machines, VMs on that host continue to run.
And that VM is then automatically restarted.
Yep.
So you're up and running immediately.
So how do I use it?
Using it's pretty straightforward, but you do have to have hardware support for it. So the biggest issue is you need to have ACPI 5.0 support for the faults. So you need to have a server that's actually enabled to support this. And then also, if you're off dealing with application programming, we have a new API that allows you to be able to take this fault, the API is Create Memory Resource Notification, that allows apps to then be able to try to detect if a particular DIMM goes bad. Say, for example, a large database may be using a huge amount of memory, but they may have portions of it that are just a read cache. And so losing a portion of that actually does not in any way affect the database, and they can unmap that memory, and life is fine.
So we let the Hyper-V host figure out if it can free it up. If it can't, it talks to the VM, asks the VM. If the VM has that memory in use by an application, it can ask the application as long as the application.
Yep. And if any step along the way it doesn't work out, for instance, say you have a VM that doesn't support this capability, say you're running a Linux VM, then what would simply happen is that one VM is just restarted, and then that piece of memory is no longer available to anyone.
All right, so disks, memory on single systems. Let's turn to clustered systems now, because in the real world, if I'm going to really count on availability, I'm going to want to make sure that I have the ability to fail over from one system to another. Mm-hmm. So we've got a number of things that we did in that, particularly around the clustering system, setup for that, and some of the services. So let's go talk about those.
Actually, before we dive in, if we could maybe just ask the audience a bit. How many of you guys today deploy clustering? How many of you do it on Windows Server 2003? Okay. It's a huge world since then.
How many of you think it's easy? Oh, a few.
Okay.
You guys are the pros.
So Windows Server 2003 is one data point for you. We completely rewrote the entire cluster infrastructure since 2003. That infrastructure was shipped in 2008 R2 in 2008. And then in Windows Server 2012, what we did is take that infrastructure and put it across pretty much all of our server SKUs and made it so it's pervasive. So that's one side of it. And the other is we've made it much, much, much easier to use and much more scalable. And so the data point from 8 years ago, I would encourage you to look at a more recent data point, because that pain point is very real. I've talked to a lot of customers around Windows Server 2003, and it's rough. And there's really solid technical reasons why you want to upgrade.
So we'll talk a minute about how we did failover for SMB and for the data access. And in order to be able to do that, we had to make sure that the applications meet our continuously available definition, that the applications didn't see the errors. That meant that clustering had to fail over the node in a fast enough time that we could meet that requirement. And if the cluster doesn't fail over for a couple of minutes, you're not going to meet that requirement. So the work that was done in Server 2012 was a massive effort to be able to reduce the failover times. They went from a couple of minutes down to under 20 seconds, sometimes much faster than that. We'll talk a little bit more about that. But Windows failover clustering in 2012, just think of it as the failover times are dramatically reduced. The scale of how many nodes you can have in the cluster is dramatically increased from 16 to 64 nodes, and the scale of how much load you can run on that is dramatically increased, up to 4,000 VMs.
As part of that, when we were going down the path of trying to understand, can we deliver a continuously available system, We did a lot of root cause analysis based on customer feedback on various causes of outages. So cascading failures was one area that we spent a huge amount of time. And then another is very large storage configurations. It turns out there's certain customer scenarios that we were seeing really serious pain points around, where it would take minutes to be able to move a service from one node to another. And in many situations, if you have an outage for minutes, that isn't anyone's definition of continuous availability. Ours was we wanted to be able to fail over anything under any situation in roughly 20, 30 seconds. And then that's worst case. And best case, and you'll see this in various demos across talks here, is we fail over in 2-3 seconds.
So some of you thought clustering is easy. Some of our customers thought it wasn't easy, particularly the ones that aren't the IT pros. They just want to buy a server and set it up, and they get completely lost. So one of the things that we did is we wanted to enable OEMs to be able to ship clusters or clustering servers and have the end user in small or medium business to be able to set those up much more quickly. So we pioneered this in our Windows Storage Server product. It's now in Windows Server, a simplified cluster setup that from one wizard on one screen will enable setup of a cluster across both of two nodes, do all of the configuration on both nodes, and you can do that in about 15 minutes. It's customizable by the OEM.
There's a talk that we'll be giving on cluster in a box specifically, where we package all that up into a single box where you have two nodes or 4 nodes, and then can fail over transparently between them and have this appliance-like feel of being able to take it out of the box and have it up and running in less than 15 minutes.
So go listen to John Lovell on Thursday, I think, right? Oh, it's today at noon.
Okay. Great.
All right, DHCP. So we looked at services, and we wanted to make the services actually work more available. So what do we do with DHCP?
Well, when we were going into what does it take to get a continuously available service, from our customers' perspective, they were seeing a lot of different sources of outages. We've already walked through a bit of the clustering sources of outage and a bit of the storage sources of outage, but the reality was they were also seeing issues in their network infrastructure. One of the issues was their DHCP that they were deploying was actually not fault tolerant, and so they would have all these services that are wonderfully fault tolerant sitting on top of it, but the core networking infrastructure that hands out IP addresses is not. And so under worst case scenarios where that server goes down, they actually lose network connectivity. To make it easy to deploy, what we've done is created this fault-tolerant DHCP server that can be potentially in different geographic regions. And so there's several different deployment options that we've heard from our customers that they wanted to be able to do. One is, for instance, 2 different data centers that are active, and they want a DHCP server that can hand out locally IP addresses, not having to coordinate between the 2 data centers, and then be able to work autonomously if one of the data centers or the WAN connectivity to that data center is lost. So that's an active configuration for the DHCP server. And then the other configuration we've heard from customers is branch offices, where what they'd like to be able to do is have a DHCP server in the branch office that's normally the always-on a branch DHCP server, and then under worst-case scenarios where that server dies, be able to fail over to a DHCP server that's in the data center that has maybe a different level of reliability, but it's only for that worst-case scenario when that local server dies. And so that's what we're calling hot standby. So either of those scenarios are fully supported. It's extremely easy to actually deploy. The actual GUI we'll walk through briefly here, and essentially all you do is on the service itself, configure failover as it shows there, and then you can set up a couple parameters. Default usually should work, and hit next, and you're done.
As Jim said, that you can do that active or active-passive thing, and it's defined by the scope of the IP addresses, the IP address ranges.
Yep.
All right, let's talk about storage. So customers told us that they wanted their data safe, they wanted it continuously available, and a big piece of feedback that they said was they wanted more options for how they could deploy storage and deploy Windows servers using different kinds of storage. So we did a lot of work around continuously available storage. We're going to show you a bit about how that works, particularly with the SMB protocol. So to do that, we had to fundamentally change the concept of how SMB, the protocol, worked. And we happen to have the Windows Server side of that, and our team owns the SMB client as well. Mm-hmm. So we worked from both ends of that to solve this problem. So why don't you tell them how it works, and then we'll show them.
I've been in 12 hours of customer meetings over the last day and a half, and what really surprised me in terms of hosters particularly is how often people deploy fiber channel SAN arrays to provide storage for their hosting environment. What we wanted to be able to do is provide additional options. It may well be that your SAN array is exactly what you need, or the other option would be to use essentially your centralized storage in a file server. So instead of having to deal with management of LUNs and trying to figure out how to expose that to your tenants, instead you have a share, and you can set up your VHDs on the share, and everything is dealt with as files, and then it's actually much easier to be able to share things out as a file server than it is as a storage array. The core capability, though, when we started sitting down and saying, okay, if that's the market we're going after, there's actually a bunch of things that were missing in the SMB protocol for us to be able to support server application workloads, for us to be able to support Hyper-V. There's a session, unfortunately scheduled right on top of this one, that goes through the gory details of how Hyper-V over SMB is supported, and I would encourage you to look at that slide deck offline. But to start off with, one of the first things that we had to deal with was the issue of transparent failover. If a server is going to be using SMB, that's a very different world than what we used to call the information worker, the desktop being able to go to a file server. That workload did not really require continuous availability. It was a nice to have, but in general, you don't have fault-tolerant network infrastructure, fault-tolerant everything all the way to the desktop. But a lot of people deploy it to servers. And so for us, what we wanted to be able to do is take into account fault-tolerant networking, fault-tolerant servers, and fault-tolerant storage in an end-to-end way, and understand under all situations how errors can be injected in, faults can be injected in, and we can transparently recover. So with SMB, normally what we do is the server, say the Hyper-V server, would connect into a single share and perform I/O against that share on a VHD, for example. So that's actually new in Windows Server 2012 to even be able to do that. Previously, we did not support going to a file share. Now we do. But if that Hyper-V is operating, say, paging to that file over the network, and that file server goes down, you basically have panicked the operating system because it can no longer access the page file. That VM is gone. That's unacceptable, of course. And so what we've implemented is this ability to transparently fail over. So the SMB3 client can detect this situation and then fail over to another server in the cluster and continue on in a transparent way. And in fact, what we found in talking to customers is that this failover needed to be extremely fast. It could not take 20, 30, 40 seconds. They wanted under normal conditions for it to take single-digit seconds. And so what we did is we designed an infrastructure that is not timeout-based. We actually have what we call a witness running in the cluster that figures out if any node is dead. And so we actually have two connections going to every client, one connection for the I/O path that's going to the file server node that's getting the I/Os, and then another connection from another node in the cluster that's this witness that tells the client if something's wrong. And so if, say, in this case, the node on the left dies, the witness protocol will tell the client immediately that that node is dead. The client will rip down all of its connections and start proactively taking everything offline. And then as soon as the resources are moved to another node, then the witness will tell the client the other node's ready and raring, go ahead, go to this specific IP address. So there's no timeouts, there's no race conditions, and it then connects back in immediately. And in fact, we actually support an active-active version of this sitting on top of clustered shared volumes so that the resources don't even have to be moved. The resources are already on the other nodes, and so failover is blazingly fast.
So I wanted to show you how difficult it is to set this up.
Yeah, it's pretty tough.
You go create a file share, and if it's on a cluster, there's a checkbox. And in fact, the checkbox is on by default. So unless you uncheck that, you get transparent failover.
There is one other point I'd like to make on this, actually. If you look at the bottom, you can now also encrypt your data. And so as you look at moving your server application workload off of Fibre Channel, for example, onto IP networking over, say, Ethernet, if you're worried about privacy of that data, it's trivial now. You just check the checkbox for encrypt your data, and you can be sure that you continue to have privacy for your PII data, for example.
So we told you about PowerShell. With PowerShell, you don't even have to check the box. It's checked automatically by default. If you want to turn it off, there's a PowerShell command to do that. So now, we told you we'd show you this in action. So unfortunately, the cluster server that I would have used is being used in Jose's demo. Right now. So what we're going to see is a SQL Server database running on...
Can you make it full screen?
No. So you can see here the database running on file server. We're going to go up and start the load, and you'll see down here in the lower right, SQL Server transactions starting to ramp up, because we just started the SQL transaction load on it. In the lower right, you can see we're running here at about 6,000 transactions per second. So it's a transactional database operating under load.
So this is an OLTP workload.
Yes. So while that's ramping up, we're going to go up and take a look at the IOPS. So we're seeing just under 200,000 I/O operations per second on this. So now, this is running against a cluster. So this is the file server SMB A and B. So what we're going to do is we're going to do maintenance on that. So we're going to go move the load from one to another. You can see the I/O transactions, the blue line, drops. It comes right back up because we've reconnected to the other node. If this was a scale-out file server, you wouldn't even be able to see that almost because it's so fast. But we now have failed over. We do the maintenance. Let's move it back. Go to the manager, the cluster manager, move it back. The IOs drop. You're back up and running. So in less than 30 seconds, we have moved the load from one file server to another, moved it back for maintenance, and SQL Server didn't notice.
What was maybe a little subtle with that demo is that it was that was actually hitting both shares, both servers. And so when you then went into maintenance mode, you had to move the workload from the two servers that were being hit into a single server. So there was actually a reduction in capacity because of that. And then as soon as we failed back again, after servicing that node, we're right back up to the performance level we were before.
Yeah, I forgot to mention that. It drops to about 4,000 transactions per second while we have all of that onto one of the nodes. So, sweet.
And for the real demo, you should be in the other talk right now.
Yeah. Let's get this back. Okay. We talked a little bit about multi-channel and scale-out. So let's talk specifically about how each of those work. So here's multi-channel. Multi-channel is the ability to take more than one network interface and more than one path between a SMB client and server, and to utilize those to increase bandwidth and increased availability.
Yeah, yeah. We actually, I have to start a little bit before that, though. With SMB multi-channel, for those that are kind of familiar with networking, basically what we did is we created a session layer in SMB3 to make it so that we can have connections come up and go down without losing any of the state that's associated with the I/O, with the handle. And so with SMB3, it's now trivial for us to bring up and down connections as needed, depending upon load, depending upon network availability, depending upon the number of connections you have, et cetera. And it's all dynamic. So why would you want that capability? Well, there's a couple pretty interesting scenarios. And actually, the first one maybe is a little less obvious. If you have, for example, 10 gig network connectivity, which I believe people are starting to deploy en masse at this point, what you'll find with 10 gig network connectivity with our old protocol is we'd have a single TCP connection that would go across the link. And so that single TCP connection would hit a single core, because we try to keep our TCP packets in order the whole time. So it goes to a single core. So what you have is a core that's essentially completely maxed out. You have a hotspot on your system, and all your other cores are idle. Whereas with SMB3, what we do is we open up a session now, and then underneath that session, open up potentially multiple connections. And so for 10 gig connectivity, what we do is we open up 4 TCP connections, and that allows us to be able to workload balance across those. And then on the other end, those cores, we're now load balancing across 4 cores. You no longer have that hot core problem that makes it so difficult to be able to balance your server. And in fact, we can do many more connections than that. And then if you add, say, a second 10 gig NIC, we will dynamically detect that. So SMB3 actually will query both ends of the protocol for what their network capabilities are. And by querying that, we can then detect, do you have, say, multiple 10 gig links? Do you have InfiniBand? We support InfiniBand now as well. Do you have RDMA capabilities? And we'll automatically bring up or bring down that depending upon what the end-to-end capabilities are. And so by that, we now not only can show really amazing scalability as we go from 1 10 gig to 2 to 4 10 gigs. We have a paper on the web, by the way, that shows linear scaling of going from 1 to 4 10 gigs. We're doing 40 gig today with a nicely balanced system, as you'll see from the paper. And then in that world, we then can fail back as well. So one of those interfaces disappears for whatever reason. Somebody tripped over a cable, whatever. Then we'll fail back, and all of this is transparent.
So you get benefits from SMB multi-channel even if you only have a single network connection in your server. If you have more than one, we'll take advantage of that automatically. If you have different kinds of network connections, we'll automatically figure out which is the best, the fastest connection. If you put RDMA, which is in John's session, we will take advantage of RDMA networks all automatically. So
we also, by the way, there's a new capability called load balancing and failover, and NIC teaming in the OS, and we also sit cleanly on top of that as well. The thing that's good about SMB multi-channel with NIC teaming is NIC teaming will take a single TCP connection and put it down a single link. For us now, what we do is we open multiple TCP connections, like I talked about before, and so it'll just automatically load balance across all interfaces. So the mere act of setting up a NIC team, now with SMB3, will automatically load balance across all of those NICs.
So what do you have to do to use this? Well, I put the little palm tree here because you can be sitting on the beach.
That's where I want to be.
There's nothing you have to do to take advantage of SMB multi-channel. It just works. As long as both ends have Windows Server 2012 or Windows 8, if it's a client, it will just work.
There are overrides, by the way, if you don't like our defaults. But in general, we've tested the defaults across a wide variety of customer deployments, and it works extremely well.
So you talked a minute ago about how you can set up active-active systems. So that's scale-out file server.
Yeah. With that, it's kind of neat. In this release, we got to play a lot of cross-team work. We worked extremely closely with the storage and file system team. We also worked extremely closely with the clustering team. The clustering team, of course, had clustered shared volumes version 1 in Win2K R2. In Windows Server 2012, basically it was rewritten to now be a full-blown, what we call pseudo-file system. But that rewrite of CSV has now made it a general-purpose file system that file server can now sit on top of. And so we're able to fully leverage all of the CSV work to be able to create now an active-active file share. So previously what we had was an active-passive file share, where a single share, a single file server, would, even though it can be in a cluster, only one node in the cluster can be enabled for that file server at a time. You can have multiple file servers in the cluster, but it's essentially what we call dual active. With SMB3, what we have is now an active-active share, where you can have a single file server, in fact, a single share that spans all the nodes in the cluster. And so it's actually extremely easy to administer. All you do is set up in DNS multiple IP addresses for that server, and that allows all of the clients to come in and load balance. So any single client will come to a single node. But if you have, say, 60 clients or something like that, they'll then load balance evenly across all the nodes. And so with that active-active capability that's enabled with clustered shared volumes, we can now load balance across all the nodes in the infrastructure. And in fact, just to really bend your mind a little bit, the reality is clustered shared volumes is actually built on top of SMB3. And so all the capabilities we just talked about in terms of multi-channel and in terms of high-speed data transfers with the new RDMA capabilities in SMB3 are all leveraged by clustered shared volumes as it redirects traffic within the cluster. And so the same high-speed networking, the same network fault tolerance that we built into SMB3 for server application workloads going to a file server is actually fully leveraged by clustered shared volumes when it has to redirect I/O within the cluster.
So we could spend a whole session talking about the different ways that you could deploy that.
Oh,
and,
yeah.
There will be lots of materials. We've already started putting materials out on the web. There will be white papers and deployment guides and examples. But this is going to be a fundamental change to how you think about how you deploy data centers going forward.
And it really is, to me, what's fun about it is it's just so easy to deploy. You no longer have to deal with the storage resource. The storage resource is present in all nodes. So when you set up your service to be continuously available with clustered shared volumes, just running locally on clustered shared volumes, the storage aspect of configuring a cluster is now gone. You just set up a CSV volume, it's present everywhere. With file server, it's the exact same deal then. And then if you're then going remote, it's just a UNC path name that you specify to, for example, through System Center. So System Center fully supports integrating all of this and having a file share as your active-active consolidated storage solution.
Okay, before we leave storage, I wanted to talk a little bit about what we've done for those of you who might have heterogeneous environments. Turns out that most of our customers do. So if you use VMware, if you use NFS or iSCSI, we have something for you too in continuous availability. We took that CA moniker, we went through the work in NFS and the iSCSI target and built continuous availability into both of those protocols.
It was interesting chatting with customers because what they were telling us is that, you know, as much as we like Microsoft, the reality is there's other vendors we work with and other solutions that we deploy. And so in terms of being able to provide a file server that's consolidated storage, what they wanted was storage that can be available to any of their properties, whether it's Linux, VMware, Hyper-V, or Windows Native. And so for that reason, we went off, created an incredibly powerful NFS v3 server that's continuously available, built on the same technologies that we just walked through in terms of being able to transparently fail over between nodes. And we did the exact same thing for the iSCSI target as well. And that's actually new in Windows Server 2012. We only had the iSCSI target previously in Windows Storage Server, which was an OEM SKU and appliance. Now it's actually part of Windows Server 2012, and anyone can turn on the iSCSI target.
It's in the box. And by the way, it's not on the slide because we didn't get the CA work done, but we also have an NFS 4.1 server in the box in Windows 2012.
Yes.
All right, so we've talked about single node, memory and disk errors, keeping your data safe. We've talked about clustering of services, clustering of the applications. We talked about continuously available storage across Windows and other platforms. Now let's talk about a little bit about how you deploy these things and reconfigure. When it turns out that although check disk was a big complaint, people didn't like it, the biggest cause of downtime wasn't check disk. The biggest cause of downtime, when we looked at the causes across the board, was I have to update my server. I have to update security patches, I have to update the application software, I have to update the operating system, I have to update the firmware, I have to take it down for some reason, and that's going to affect my uptime. So we took a look at that. We looked at reconfiguration of Hyper-V deployments, and we looked at patching servers, and we have some goodies for you in both of those cases. So in Server 2008 R2, you could do Hyper-V VM live migration. We've gone beyond VM live migration. In Server 2012, we can do Hyper-V storage live migration. Tell us about that.
The storage migration feature is really powerful for a lot of new scenarios. One is that you can now, as you're end-of-lifing your existing storage infrastructure to the latest generation technology, which, as we all know, the cost of storage is plummeting like a rock. And so there's an awful lot of scenarios where you actually are end-of-lifing your existing storage infrastructure. This allows you to do it while you're online the entire time. There's no downtime. And so you can storage live migrate your VHDs off of your current storage infrastructure to your new SAN array or your new file server, et cetera. It actually allows more scenarios than that. It actually allows you to do things like load balancing. Say you've got a series of clusters, say 4 or 5 clusters, and you've got a set of services that you've scheduled for cluster number 1, and you're finding out that today things are way overloaded on that cluster. You'd like to rebalance. You'd like to actually shed load off of that cluster, put it on some of your other clusters. You can now, through the combination of live migration and storage migration, migrate both your storage and your VM between clusters. And in fact, you can even do that across geolocations. So it's extremely general to be able to support now both live migration and storage live migration.
So it doesn't have to be the same type of storage, doesn't have to be the same vendor. As long as we can reach it, we can move it.
Yep.
Updating, patching. So as I said, this is the biggest cause of downtime. So we decided to make that easy for you as well. So we built a new service called Cluster Aware Updating that will orchestrate the updating and patching of servers across a cluster. You tell it the cluster, it integrates with the Windows Update service to be able to figure out what patches need to be applied. There are third-party plugins that you can plug in for firmware and other kinds of upgrades. It will determine what's necessary, shed the load off of the it'll pick one of the nodes, shed the load off of that, put it in maintenance mode, move things onto other nodes of the server, run the updates.
I'm sorry, as a geek, I just got to dive down a little bit further if that's okay.
Well, I got to tell them the big picture so you can tell them the details.
So to me, this is one of the more fun pieces of technology that we have, simply because it combines so many different technological components together with just one little button click of the GUI, or PowerShell as the case may be. So first off, let me walk you through a somewhat complex example to give you a feel for how simple the actual end user experience is. So say you've got a cluster, say it's an 8-node cluster, and say that cluster is a Hyper-V cluster, and you've got a centralized file server that you're now sharing your storage across, and you need to be able to patch your file server. And say your file server is 4 nodes. In the old world, what we would do is you would take an individual node down. The act of taking that node down would cause the file server to move from one node to another. That would invalidate all the handles that are currently open. And so any VMs that are actively doing I/O against the file server would quite possibly crash. And so because you don't want a customer to see that, you'd have to bring all your VMs offline first before you did that maintenance operation. With the new capabilities, what we do is when you want to be able to patch that particular node, well, first off, you're not doing it. You actually set it up to be completely automated. So by that click of the button, you can now set up a schedule that says, I want to run my patches on Patch Tuesday at midnight or whatever. And that will then cause a rolling upgrade. So the first node, we will migrate all the load off in a transparent way using the SMB3 failover capabilities. So there's no downtime at all from the Hyper-V host perspective. And then when you take that node into what's called maintenance mode, you now have the ability to run operations against it, whether you're patching the operating system, patching the BIOS, patching an application, whatever it is that you're patching. You can then extend it to run your own acceptance criteria tests to make sure that the patch was actually successful. And then once that has succeeded, you'll then bring the node back into the cluster, and then we will automatically take the load that was previously scheduled on that node back to that node, excuse me, and then go to the next node. And all of this is done completely transparently. So it's a brave new world, really, in terms of this cluster-aware updating. And the same technology, then, you can apply to the Hyper-V cluster as well by transparently moving through live migration all of the VMs. Say you've got, say, 100 VMs on a particular node. Say you're running VDI. We will shed all those 100 VMs onto other nodes with fairly sophisticated prioritization mechanisms to make sure that you have the right priority VMs running in the right spots. And then bring that node out of the cluster into maintenance mode, and then patch it just as I walk through, and then continue on a rolling way through the different nodes in the cluster. So it's kind of a neat little combination of a lot of underlying technologies.
So not only do we have a lot of different things in Server 2012, they work together. And
yes,
that's a great example of how we've put multiple technologies together and then orchestrated the solution to make it really easy for you. So we've talked about OneNode. We've talked about the clustering and available services. We've talked about now the deployment and updating. Let's talk for a minute before we run out of time about multi-site. So even if your server is highly available or continuously available on site, people still tell us we need to be able to make sure that we have some option for having a replica off-site so that if I have my whole site go down, I can keep my business in operation. So we made this easy as well. There are lots of ways to do this. They tend to be expensive and challenging and difficult. We made a pretty simple solution, and we'll show you in a second how easy it is. But Jim, tell us how it works.
It was interesting in chatting with customers. One of the big areas that people were not deploying any form of disaster recovery for was in small, medium businesses. To be able to get them to the point where they've got the ability, all of them said they wanted it. They all said it was either too expensive or too complex. And often complexity maps to it's not actually working properly. They haven't configured it properly, aren't maintaining it properly. And so what we were really focused on, one, was solving this problem for small, medium businesses. But honestly, the other side is the core technology performs extremely well, and it's all very orchestratable through PowerShell, and so it's actually useful in the enterprise deployments as well. The core capability is that if you're running in a Hyper-V environment, we take the existing VHD file that you're running and essentially ship a log to another site. And so we've done a huge amount of work to make that very performant so that the cost of actually doing it effectively, these dual writes, it is an asynchronous process, so you don't directly affect the scalability of the service by it. That replica then gets shot over to another DR site, and then the VHD gets resurrected from that log file shipping. And then if a DR event occurs, if you need to be able to enable that DR site, we have the tools to automate patching the IP addresses in those VHDs to then bring that service up fully functional. You've, of course, got a little bit of a blackout time in there because it is asynchronous replication, but it's also extremely easy to use, and honestly, the other side is won't have that same high performance requirement of the wide area network.
So it's how easy to use? Let's take a look.
Yeah.
You go into the Hyper-V manager, select your VM, specify a target. All you have to do is be able to find a Hyper-V host someplace accessible on your network that you've had the switch flipped to be able to accept a replication. For security reasons, you have to tell that server that it should be able to accept replication.
Yeah.
You specify the server, use either certificates or Kerberos as authentication. It automatically identifies all of the VHD files that are associated with that VM. Gives you the summary, click next. So it's specify the server, next, 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 you're done. Yep. It's a manual process, as Jim described, to bring that up because we don't assume that we can make the decision for you of whether you want to take the data loss for the few minutes between replication or whether you want to try to get your original server back up. So you have to make that choice. But getting it replicated is that easy. PowerShell, same kind of thing. You designate the VM where you want it, authentication type, and you are done.
Pretty straightforward.
So we've talked about a lot of stuff. What's it all mean? Windows Server 2012, more availability, it's built in, and I hope we've shown you it's easy to use. There's flexible, low-cost, continuously available storage solutions for Hyper-V and SQL that come out of that enable higher availability of those applications and of the systems that you run in your data center. So with that, there are some related contents. I'd urge you to attend any of these other sessions. There's another set of sessions, as I said, that were in the North America TechEd, and I put links here. You can go grab the decks and watch the videos of those as well. So with that, we'll take questions, and please do the evaluation. Thank you very much.
Thank you. Any questions? Yeah. So the question is, can you schedule the replication? And yes, as part of the configuration, you can set up how often you want to replicate, and whether it's an app-consistent replication or a crash-consistent replication. Yeah. I'm sorry, could you say that again, please? Yes. So the question is, for the continuous available file server, what effects do you have from from older clients, for instance, Win2K R2 or Windows 2000, et cetera. So for a CA file share, they will be able to connect in. What they won't be able to do is have continuous availability. That's the biggest trade-off. Yeah. Can you set app-consistent snapshots in replication? Yes. So you can set, there's actually, for the Hyper-V replica, they have the ability to use both app-consistent and crash-consistent snapshots. App-consistent has more overhead because the app potentially has to flush its buffers. So, for example, you may want to set an app-consistent snapshot to be replicated every hour, and then do crash-consistent, say, every 15 minutes. Something like that. So yes, you have complete control over the granularity of both. Yes? So the question is, does Configuration Manager work with clusterware updating? And honestly, I'm not sure exactly what the integration point is. I believe it should. What I've worked mostly with is SCVMM. Honestly, there's a parallel talk that's on right now by the Hyper-V guy that would probably be able to answer that. If you'd like, though, let's take it offline. I'll get back to you. Okay. In the back?
Other questions?
Is there an SMB3 client for Windows 7? Unfortunately, no. The core issue that we found was to create continuous availability. It wasn't about creating one system or fixing one component. What we found was we had to go off and fix PNP because PNP would take under certain situations too long or get in the way of being able to transparently fail over. We had to fix issues in clustering. We had to fix issues in the file system. There was a lot of different components that had to come together, and then we had to test it all end to end. So we have a pretty massive test infrastructure, to be able to ensure that it works end-to-end across all these different cases and making sure that we never regress, no matter what happens in the code base. And so that effort is extremely difficult to backport, unfortunately. So at this time, anyway, we're not planning on backporting any of it.
So they're compatible, as Jim said. You can use those systems against a Server 2012 continuously available server. You'll get the same level of availability that you would against a Server 2008 R2 server. You'll get good performance and all of that, but you won't get continuous availability unless you have Windows 8 client or Server 2012 client.
Now, if you're actually deploying Hyper-V, the only thing you have to do is upgrade the Hyper-V node. And so the VMs within it will transparently use SMB3 going through the Hyper-V Windows Server 2012 and then redirecting to the file server. So you don't have to upgrade the VMs, just the host.
Yes? So the question is about cluster-aware updating for SQL Server. So there's some work that has to be done with the applications. I believe we have fully tested that with SQL Server with their upcoming release, so that with the new version of SQL Server, it will work on cluster-aware updating and be able to patch through a cluster with SQL on it.
So SQL Denali specifically supports the capability. SQL Denali, SQL Server 2012. Yeah. Other questions? Back there? Right. No. So I think the question is, if you have a SAN, do you have to use storage spaces? Is that the question? Absolutely not. So there's really what we're doing is just extending options. And so in this talk, we introduced a new form of reliable storage called storage spaces that's really intended to be used if you want to deploy shared JBODs, not storage arrays. We fully support storage arrays. We've got a lot of new capabilities that we support in storage arrays, so there's no issue at all with deploying storage arrays on Windows. And in fact, we've got new features like better thin provisioning and offloaded data transfers that we've worked with our partners in the storage array industry. With storage spaces, you now have a new option. So you can take just JBODs and then through spaces, through software, make that reliable storage. We actually have a third option as well that we'll be going through in the Cluster in a Box talk, where our partners have extended RAID drivers to be clusterable. And so that RAID write-back cache is now mirrored between two nodes, and that's also now made continuously available. So there's really three different reliable storage solutions on Windows now. Previously, we only supported storage area networks. Now you can use shared JBOD through either storage spaces or what we're calling clustered RAID controllers. Yeah. So the question is, if you're using parity to protect your data, what's the recommendation? And honestly, to me, it always comes back to what's the workload. So with spaces, if you're clustered, it does not support parity disk. It only supports mirrored disks. So only in a standalone node configuration does spaces support parity disks. So if you want to use parity in a clustered configuration, the only two options are either this clustered RAID controller I just talked about or a storage area network. And then it comes back to what the workload is as to whether RAID 5 or mirrored or a RAID 6 or other options are better. Yes. Well, no, it's actually, I mean, so the question is there some performance issue in doing it in software versus doing it in hardware? And what's been interesting to me is if you're, the reality is the CPU these days is pretty powerful. And so the raw throughput you get can be absolutely incredible with storage spaces. Amazing throughput, either IOPS or bandwidth. However, yes, it is using the host CPU. And so if you don't want to do that, you can certainly offload it either through these clustered RAID controllers or through a storage area network. And then you can have more of the CPU back to do other things.
The critical point is pick which strategy you want to use. Don't try to say, I want to combine parity from hardware and then use storage spaces and put mirroring. You'll get yourself confused. Just pick one of those options. We want to give you more options to choose from. But if you've got a SAN array, for instance, that you're really happy with and it's doing all that stuff, just use it.
Yeah. It is probably worthwhile pointing out with the file server, you actually effectively offload the storage stack. And so if you're redirecting, say, a Hyper-V cluster, previously would have been on a storage array, running the entire file system locally. With a file server, what we do is we actually redirect all of the file system operations to the file server. And so you actually get lower CPU utilization when you go to the file server over SMB3 with the RDMA capability than you would if you had a local fiber channel adapter, for example.
So our red light is blinking. I think we're going to have to we'll go outside and we'll take questions from anybody out there, but we need to free up the room. Thank you very much.